on. So we have a multiple interacting controllers. These are for the cooling fans, oxygen supply, compressors, humidifiers, hydrogen management, the charge regulation, the control of the electricity that comes out of it. All of these have to be balanced. They are contradictory requirements in many cases, and that's what our algorithms do. So that is our major input in running the systems at a most efficient level. And that leads to our increased, so our intellectual property sits in our control methodology, which is different for every application. So we have a whole bunch of potential patents or intellectual properties defined, which is not, when we started we were thinking there's only one, but every time we've developed our Delta process, we've come up with another algorithm. So we have a whole bunch of intellectual property algorithms that we can encapsulate in patents if that's necessary. We've developed our own cell monitoring circuit, which can be sold separately, our own DC-DC charge regulator for the supercapacitor, and we have developed techniques for our modular integration systems for each application, and I'll come on to that a little bit later on. So all of this is added, this has all been done within our project in the last 2 years to take advantage of the grant given by the Southwest RDA and make us ready for the market. What will come next will be the hydrogen storage and handling provisions, which when Professor Guo's technology is ready, we will be incorporating that in part of our offerings. So what benefits do fuel cell systems offer? They have no moving parts. There are no flames involved, there's no combustion, therefore there's very little to wear out. The only thing that wears out is the catalyst, that gradually gets contaminated. So at the moment the fuel cells are at an early stage of development, and 10,000 hours running time is typically what is available from the fuel cell developers, and that means if you were driving your car, in car terms, if you're driving your car at 30 miles per hour, that's a service interval or an engine life of greater than 300,000 miles. So that means your true life costs are much lower, although the initial price might be higher in comparison with petrol and diesel engines. They're quiet because they're electrical systems as compared to diesel or petrol-powered systems, and they have zero emissions because what comes out of the exhaust is water, steam, and that can be captured and reused somewhere else. Normally fuel cells are 2.5 to 3 times more efficient than the internal combustion engine. When your car is brand new, it's 35% efficient. Everything is brand new. It's a perfect day, 20 degrees centigrade as it is today. It's 35 degrees, it's 35% efficient. When you start driving it under load, it's typically 16% efficient. The equivalent numbers for fuel cell systems are in idling, they're at 80%, and when they're under load, they're down to around 50%. With our algorithms, we can improve that by 30% under load. So what does that give you? Increased efficiency means lower fuel costs and improves the competitive position of your operation, whether it's a company or your personal bank balance. So our focus on the global market is led us to develop our system for a range of products that we've been aiming at. We have, as I mentioned earlier, we've developed our own control systems and monitoring systems for fuel cells, which the likes of ACAL Engineering and Intelligent Energy are interested in, so that produces a market for the electronics in itself as a self-standing items. Our initial entry points are into electric forklifts, and there we're talking to all of the supermarket groups and other distribution groups, and we have signed a memorandum of understanding with one group where we will be taking our product for initial introduction. The next easy introduction point, easy is overstating, is UPS, uninterruptible power supplies and backup power, which are used everywhere in this building, in any business, to safeguard the business. And that is a new market which we hadn't originally considered, but has come to us. Now, whilst there's a recession in the UK and in Europe and America, the world is still open for business. And one of our competitors, a US-based competitor, has secured an order for 10,000 units to be supplied to an Indian telecoms company for backup power. UPS and backup power becomes combined in this scenario. And they have an option for another 30,000 on top of that in the next few years. So the market is out there to be had, and we should be getting some of it, Auriga Energy and the UK in general. And that's what we're aiming at. The next item that we've got is ferries and water taxis and canal boats. And we've been talking to Bristol City Council in relation to converting some of the harbour boats and the ferries for hydrogen-powered fuel cell systems to reduce the pollution that's coming out of the ports and harbours. This morning's news concentrated on the pollution at airports and saying that we need to reduce flying or tax it or achieve the savings elsewhere. One area that gets missed, and I've got tons of papers on the assessments, are harbours and ports, which are pollution bubbles just as much as airports are. If you ever took a picture of Avonmouth or other very busy ports, and they're just a smog bubble. So that's an area to be addressed, and we've chosen to go into that as an option for our introduction into the industry. We've also been to Dubai because, as you know, they're developing the World Island, the Palm Island, and numerous offshore developments in the Gulf area, which will need a lot of boat transport. So the market is there, and it's to be opened up and had. We have an expression of interest from the Metropolitan Police for a patrol rib to be patrolling along the Thames. This is to be financed by the Mayor's office in London. And we're in partnership with Chameleon Craft, and that's one of their boats that you see there, which is proposed for that operation. This gives us a product line of a variety of outlets, which gives us inertia to build our business and make sure it's successful and get a good cash flow out of it. So just a few points. For materials handling, forklift operations, what it gives you is greater at the moment, electric forklifts which operate inside warehouses are battery charged systems. Fuel cell systems can give you almost infinite life as big as your tank is, and refueling is as refueling per your car within 2 minutes or 3 minutes. Whereas a battery runs out of its charge within 5 hours and takes 8 hours to recharge it. They then have to maintain a spare battery on charge, and that takes up a lot of space within the warehouse. It gives you consistent power, whereas a battery, as it drains, will lose power, and therefore you're getting less performance out of it. And it has all the environmental benefits that I mentioned earlier on. UPS systems give you almost infinite running time, because they're not just UPS now, they can be backup power, because you're no longer dependent on the stored battery energy. You're now only dependent on the size of the tank that you put in. So the hydrogen tank is the limiting factor. They can be stored inside for computer rooms because they are quiet, clean, and there's no planning permission required for these. And there's a wide operational range, so they can go in a very cold environment as well as hot environments. Again, the benefits are lower through life costs, although any new technology is a little bit more expensive than the technologies that you're replacing at any one time. So I don't have any dynamic pictures I can show you, because fuel cells, as I said earlier on, don't have any moving parts other than the fans whirling around. So I gave you a picture here of our fuel cell development model, which we displayed at the event in Hewlett-Packard, the Swerder event in Hewlett-Packard last year. And that's what it looks like. Our fuel cell system is very compact, and then there are a couple of screenshots of how we control the system and how we monitor it. And that is where we are. We've developed our system in the laboratory, we're proving it and moving along to the next stage of taking it to the end customer for exploitation. We've been operating out of Set Squared, and I'm grateful for all the help that Nick Sturge is giving us. And I'm doubly grateful to Dr. Mike Tierney of Bristol University, who gave us some lab space to help us bring the business to this stage. And